Hey guys, today we are going to kickstart our networking core thing. So from today's we will be starting with what you mean by circuit, what you mean by node, what you mean by branch, and those kind of interior things that we'll be starting from today's lecture. So let us kickstart our networking with the concept what do you mean by circuit. So connection of network element such that there exists a closed path of flow current is called as a electrical circuit. So generally which is nothing but an interconnection of components. So connection of network elements with closed path. So that will be called as the circuit. So with the closed path. Okay. So if there is an interconnection of different network components or elements with some closed path, then only that will be called as the circuit flow. So if we take the example, so let us take a RC connection. So if we take the thing, so this is RC, so capacitance and resistance. So RC. So here it is like this, and there is another one circuit. The same, but if you see that is get connecting to a battery and the circuit is closed. So if you see there is a difference between these two circuits. So if you see, so here if you see there is a connection of batteries there. I will connect to that. Wait a minute. So here if you see, so this here the terminal is connected, and here you see the current will flow in this direction. So here if you see there will be no current flow because it's an open circuit. So this is not a circuit generally. So this will be starting as a not a circuit. Okay, so this will be a circuit because here you see that different network elements are get interconnected, and also there is a closed path for current to flow. So this is how the quite difference between circuit and the normal network thing. So the closed circuit need to be there, and the current and the interconnection of component need to be. So that is only we call as a circuit. So let us take what you mean by network. The subject is even network theory. So let's relate the concept here. So interconnection of elements such as resistor, inductor, and capacitance that may or may not have the closed path. The thing we saw, right? So interconnection of component. So interconnection of network elements that may or may not have the closed path. Okay. So this is what the thing we have to take into account. So if we take the subset Venn diagram, so how this can be represented is that all the circuits are network, but all the networks are not a circuit. Okay. Here if you see, so this one called we can call a circuit. So circuit is the thing that we need to have what the closed path. This one can be called as a network because here the circuit may be open or may be closed. So that's why the circuit is the subset of network. So all circuit are networks, but all the networks are not called a circuit. Okay, so that is what the conceptual relation between those things. So please make a note of it. So now let's get into what do you mean by node and what do you mean by branch. So node we generally state as n, small n. Okay, so a point in a network where two or more than two elements are connected together. So this is called a point in a network. A point in network. Please note there is only a point in network. So relate all the terms that I am stressing out. So a point in a network where two or more elements, where two or more than two elements connected together. Okay. So we'll call that point as a network. So generally the degree of node which is nothing but the number of elements connected to that. So If the degree of node which is 2, so this is called degree of 2, the sigma light symbol, right? So this will be, so if it is 2, then that is simple node. Okay, so if the degree of node is greater than 2, means 2 or more elements is getting connected to the same network, then we call that as a principal node. So that is what the normal difference between these things. Please make a note of it. So then what do you mean by branch? So we start with a small b. So circuit element consists of two nodes are called branch. So two nodes are called branch. So simple. So two nodes will be called as the branch. So a degree of node means nothing but the interconnection of components. So let me write it here. So degree of node. So degree of node. So which is nothing but number of elements connected in the node. So number of elements connected to a node. So that is what we call as a degree of node. So we can state that as an example. So now let's discuss what you mean by mesh. So mesh will be stated with a small m. So the formula for mesh will be m, which will be equal to branch minus node plus 1. So this will be the formula to attain mesh. A closed path in a circuit, that path that starts and ends at the same point. So it may not contain any other loop inside it. Okay, so there should not be any loop, but it need to be considered as a mesh. So let me give you one example. So what is the difference between mesh, branch and a node? Let me draw one simple diagram. So let's consider this as one network. Okay, so consider these all the lines are wired strips. Okay, so these all are wired network. So let me connect this completely. So this is how this is got connected. So if you see, let me use a red pen. So these are all individual points. So this is one node. So this is one node. So this is one node. So all the points I am marking in red are node. So this is called node. Okay, so because we know in a network, all the point where two or more elements are connected, right? So that will be called as the node. Okay. So branch can be called, which all other things will be called as a branch is that this thing. So this two node interconnection is called branch. So this is one branch. Okay, even this is called one branch. So this complete one is one branch. So these are all some branch we may call it. Okay. So mesh, what I mean by mesh is that the mesh need to be a complete loop that starts and ends at same point, but which should not contain any other loop inside it. That is what. So if we consider this one, so if we take this one, so this one is not a mesh, because if you see in between another one line is there. So this is loop. Okay, so this is loop, not a mesh. So this is loop, no, but not mesh. Okay, but this one is mesh. So this is how we will be calculating. There is one formula to calculate the mesh, so don't mistake those things. Yes. So now let's take a difference between loop and mesh. So here let us discuss what you mean by loop. So loop L. Okay. A closed path inside the network that starts and ends at same point, but it may or may not have the smaller loops inside it. So the same Venn diagram that we are going to use here. The thing is that there we have C circuit and networks, right? So similar to that, here also we'll be going to see one thing. So here if you see, so the inner circle will be called as mesh because that should not have any interior element within it. The outer one will be called as a loop. So all the mesh are called as loop, but all loops are then called as a don't cannot be called as a mesh. So that is what the difference. So now let us go to the practical circuit diagram so that you guys can understand it more clearly. So let me draw a few circuits so that you guys can understand, guys. So let us take a simple network. Then I will give you homework for you guys so that you guys can write. Okay, so let me use erasers to, this cannot be erased. Nice. Then wait, let me draw a circuit. So let's take another one interior connection between this one. So let us now connect the resistor elements. So I have taken a simple network here. So now you guys are going to answer my question. So let me draw the network element. So here I am going to connect a voltage source. So which is plus minus V. So here I'm going to connect the resistor. So here I'm going to connect another one resistor. So here another one resistor. Okay, so sorry for this resistance. Okay, so here if you see, we have connected 5 resistance over it. So now we are going to find out the number of nodes, number of branch, number of mesh, and number of loop over it. So that is what the question you are going. So this is very simple case. So how we can solve is that. So please pause the video and you guys can also try it. This will be very simple because I already explained you the concept. So let me solve this now. So now we have to branch each, name each nodes. So this is A. I'm going to name each nodes. So this is A, B. So this will be C. This can be called D. As these, there is no element between. So this one will also be called as T because this is short. So this will virtually act as a short because there is no inter element, right? So both will be same, considered same. So this will be E because there is no element. Okay, so please make a note of it. So there is no element. So both the point will be called as D. So now if you see how many points we are getting, 5. So nodes will be 5. Okay, so this will be very easy. Now we are going to find out the branches. So branches is simple thing that between the two nodes we'll be considering that as a branches. So let me take this one. So this is first branch. So A1B second branch, B2C that is third branch, C2D third fourth branch, B2D fifth branch, and D2E sixth branch. So there are 6 branches in this network. So we know the formula to find out M, that is B minus N plus 1, that is 6 minus 5 plus 1, so it should be 2. So here if you see the 2 loop is that this is one loop and this is one loop. So this is one mesh and this is one mesh. So that is X and Y, so there is 2. So how many loops is there is that? So loops means X and Y is one loop and this whole is one loop. So that is Z. So how many loops is 3? Okay, so this is how the node, branch, mesh, and loops can be found out for the circuit. I am giving you another one homework. You guys please try it. In next class we can solve this question. Okay, so let's take the simple circuit. So let me draw it. This is simple normal interconnection. Instead of connecting this with the straight lines, they are connected this with some other curved like structure, normal wirings. So please don't confuse yourselves. So every branch has the interconnection of elements. Okay, so here the voltage source is connected, that is plus minus 10 volts, and here the resistance is connected. Here one resistance is connected, here one resistor, here one resistor. Okay, so this is 5 ohms, so this is 2 ohms, so this is 3 ohms, and here if you see here I am going to connect a current source, not a resistor. So here we are going to connect a current source. So current source which is 2. So this is called current source, this is called voltage source. If you guys have any know, please make a note of it. So now here you need to find out the nodes, branch, mesh. That's it. 3 will be fine. Loops will be quite confusing. So please leave the loops and please find out. So this is the quiet homework for you guys. So please solve this one. So once you guys solve this one, we can start to get the thing into next lectures. Next I will be starting with some other explanations. So please try to solve this question. In next class I will be solving this one. So this is homework. Okay, so please like, share and subscribe channel. So please motivate me to post more videos like this, guys. So please like, share and subscribe channel so that I will be more going, they will be continuing to give the good lectures like this. Thank you guys. Stay tuned, like, share and subscribe channel.